Hello and welcome to part 2 of lesson number 11 in Unit 2B, Quadratic Functions, Forms and Transformations in our grade 11 University College math class. This is how to find the equation of a quadratic given a graph or a data set. So in the first part of this lesson we went over how to find an equation from a graph. We're now going to jump right to how to find an equation given a data set. So the only difference between a data set and a graph is that a graph is already laid out on the coordinate plane for you, and you can assume that the lines connecting each discrete point are going to sort of be following the pattern of the parabola. A data set's a little bit different in that you don't always know exactly what it's going to be modeling. The steps in a lot of ways are very similar. The first step is to actually take the scatter plot of data and graph it by hand or using technology. Now we're going to be focusing on doing this by hand. By technology, you'll see there's a note there partway down the page that refers a little bit about how to use technology to figure this out. I'll mention it briefly as we pass it by, but that's certainly not the focus today. So we start by taking our scatter plot and putting it on the graph. Now I've already done it. You'll see here that I've already put a scale on this graph so that it's a little bit easier to I guess to just sort of follow along what the scale should be. So I've gone up by 2 for every block. So I've got the table filled in, or the scale put on, and I've got the points plotted from our table of values. If you need to, or if you'd like to, maybe hit a pause right here, and then you can fill this this graph in, and then when you come back, we'll continue to talk through the procedure. So do that now. We'll see when you come back. Okay, you're back. We've got it graphed. Looks like this. It has a parabolic shape, kind of, sort of. The next thing that we're going to want to do is, if we're trying to find the equation, is go right back to the thing we were doing when we were given the graph. Is now we're going to strive to find the vertex. Now, as I said I said just a moment ago, it's hard to tell exactly where the vertex is going to be. The way that I've sketched this through, you can see that the point that we have as our highest point isn't necessarily exactly where our vertex would be. However, it is the highest point that we know for sure. So that's the one that we're going to be calling our vertex. So our vertex is the highest point that you reach. So we're going to have an h value of 24, and we're going to have a k value of 56. And that's where we're going to begin. So even though we might not think it's the exact highest point, it is the highest point that we've been provided. Next thing we're going to do is find another point along the curve, another point that we've been given. The easiest one for us to do, of course, is going to be point 0, 0. Not a lot of action there, so we have 0, and 0. Those are going to be our x and y values. X equals 0, y equals 0. And from here we do exactly as we did before, which is we take the vertex form of our quadratic, which is y equals a, x minus h all squared plus k, and we're going to substitute hk and an xy value in. So let's do that right now. We have h and k. H and k are a little bit bigger this time. You might want to use a calculator. I will be. So we have 24 in there for h, and then our plus 56 for k. Our x and y, on the other hand, are quite small. So let's just pop those in. We've got 0, and we've got 0 here. So following BEDMAS, we now have 0 equals a bracket negative 24 squared plus 56. Let's do 24 squared. Or sorry, rather negative 24 squared. That's going to give us 576. So we have 0 equal to 576a, and that's plus 56. So let's get 56 over to the other side by transposing it, subtracting 56 from both sides. So we end up now with negative 56 equals 576a. How do we get a alone? Divide both sides by 756, or 576, sorry. And let's see what we get here. So I'm going to type that into my calculator. Negative 56 divided by 576 is going to equal, so 0.097, etc. So we're just going to do an approximation here. So negative 0.0, let's just make it 0.1. That's an ish. Equals approximately our a value. So from here, same as before, we now have an a value. We're going to say, therefore, our equation is going to be f at x equals negative 0.1 bracket. That's the replacement of the a value minus, or rather, x minus 24 all squared plus 56. So there is our equation. We could do this for a second point. I'm not going to spend the time to do it now, but here's what I will say about it, is that when you're working with a table of values, just a data set, the reality is this is a less perfect way of coming up with it. If we were to pick any other point on here, whether it's point 50 and 0 or point 44, 19, whatever it is, we're going to end up with something very close to negative 0.1, but it might not be right bang on negative 0.1. Again, we've rounded it, and that's just a limit on finding the appropriate A value for a set of data rather than a graph. I also want to reference, as I said I would up here, when you're using technology to model a set of data, there's something called regressions. And regression is just sort of a fancy way of saying, computer, if you were to guess, based on this data, what a polynomial with a degree of 2 would look like modeling this data, what would the equation be? Essentially, you're asking it to imagine you were to put a parabola over top of this. You can do all sorts of different regressions. You can do exponential regressions. You can do power regressions. You can do linear or cubic regressions as in the polynomial family. As I said, we're not going to spend any time doing that right now, but it is also a possibility to use technology to do what we just did by hand here. And obviously, it's a little bit easier, but it's important to just know how to do it. So there you go. That's the end of this lesson. There's some homework listed here at the bottom. If you have any questions, as always, reach out via email, in person, in our online video chat that we have going every day. However you have to, get the answers that you need to conquer the homework, and we'll see you in the next lesson, the last lesson, lesson number 12.